Hey guys, this is Yicheng, and my teammate is Webb Williams. And today's topic is do pilots make up time in the air? One second. Um, first question is relationship between made of delay time and distance. So firstly, we create a new variable, total delay time, and which is departure delay time minus arrival delay time. And if total delay time is less than 0, which means the pilots did not make up delay time in the air, and vice versa. So we build a linear regression model, and here's the estimated equations. For interpretation, for intercept term, it is a flight that flew 0 miles is estimated to have delay for 5.97 minutes, which doesn't make sense. So it's the extrapolation. For slope term, for 1 mile, the increases of distance of the flights, the total delay time increases 0.2 minutes. And we are 95% confident that when the average flight distance increased by 1 mile, the total delay time increased between 0.2 and also 0.2 minutes. And the other relationship is the delay time and departure delay group. So here's the estimated equation from the linear regression model. And we set the group 4 as reference to see the difference between group 4 and 7. And here's the density plot, and it seems there's no significant difference between two groups. And the p-value of coefficient is 0.9, so it's not statistically significant. So there's no significant difference between group 4 and group 7 in delay time. Okay, so.
So next we wanted to look at, if we're in the case of a flight already being delayed 30 minutes, what was the relationship between the total distance of the flight and that flight ended up being greater or less than 15 minutes past its original arrival time. And so we built a logistic regression model for this that'll give us the odds depending on the distance in miles. And that equation is e to the negative 3.735 plus 0.0007576 times distance in miles. So what that means is since that coefficient is negative, that on average the distance, if a flight is already delayed more than 30 minutes, the greater the distance the flight is, the less likely it is to arrive more than 15 minutes late. So here are some odds and the probabilities that go along with them for 4 distances, 300 through 2,000 miles. And so the odds can be interpreted as, in the case of 300, for every flight that is 300 miles and was already delayed 30 minutes, that gets there less than 15 minutes late, there will be 33.37 that get there greater. And to the right of those are the probabilities, along with a 95% confidence interval, low and high. As you can see, the probabilities are pretty bad until you get to 2,000 miles, which is a really long distance flight. And then there's a decent chance of it being less than 15 minutes late. And onto our confusion matrix, we had a really low sensitivity, which is the percentage of flights less than 15 minutes late predicted correctly, but a really high specificity, which is the percentage of flights greater than 15 minutes late predicted correctly. So overall, our model is really good at identifying which flights that are already late would be greater than 15 minutes late, which makes sense because there's a ton of them. There's 50,000 of those compared to 21 that were less than 15 minutes late, and we only got 1 out of the 21 right. So overall, while the pilots did seem to make up distance in the air, or make up time in the air, it must be a really long distance flight, basically 2,000 plus miles, for them to have even a 10% chance of arriving no later than 15 minutes past the initial arrival time. And as I mentioned earlier, our specificity was great while our sensitivity was low, meaning really if we had just predicted that every flight was going to be greater than 15 minutes late, we wouldn't have been that much further off than where we were. But again, we just wanted to present what we found. And I'd like to thank you all for listening and turn it over to the board for any questions.